Assalamu alaikum wa rahmatullah. Good day everyone and welcome to my YouTube channel today. Today we will be solving the second problem on electricity. Problem 2 says it has two parts, A and B. The A part says a current of 2 milliamperes flows in a resistance of 22 kilo ohm. Determine the voltage drop across the resistor. The second part, which is the B part, says a current of 25 microampere flows in a circuit. What charge is transferred in a time interval of 40, this should be a question mark, 40 milliseconds. Okay, solution. Let us start solving as quickly as possible. Solution. Let's start with the A part of the problem. According to the A part of the problem, let's try drawing the scenario. You have a resistor, a standard resistor. Okay, the value of that resistor, capital R, is given as 22 kilo ohm. This is 22 kilo ohm. Now a current enters into this resistor. The magnitude of the current entering is this one. This is your I, this is your R. Is given as 2 milliampere. So I is 2 milliampere. Now the potential difference is what you are asked to find. Determine the voltage drop, meaning between this point, if this one is connected, is actually connected in a battery, okay, then there will be voltage drop across this resistor, and the voltage drop is given by V. The question is, find this voltage drop. The voltage drop is the work done in moving a unit positive charge from one point to another across the resistor. Like if I have a charge of 1 coulomb, the amount of electrical work done in taking this 1 coulomb of charge from this point to this point across the resistor is what we call potential drop across this resistor. Okay, here we have to use Ohm's law, but before that we must convert our I and R to their corresponding SI unit. I is given in 2 milliampere. Remember, milli is 10 raised to the power of minus 3, so this should be written as 2 times 10 raised to the power of minus 3 in ampere. Your R is given in 22 kilo ohm. The kilo here is for 1,000, 10 raised to the power of 3. So this is 22 times 10 raised to the power of 3 in ohm. Now they are in SI units. So look at it carefully. The milli is 10 raised to the power of minus 3, but the kilo is 10 raised to the power of positive 3. Now you can use the relationship between V, R and I. It says V is equal to IR from Ohm's law. After writing the formula, then we substitute the values we are given. We are given I as 2 times 10 raised to the power of minus 3. This is our I. Then we are given R as 22 times 10 raised to the power of 3. Now this is equal to, you can see that 2, you can combine these numbers here, 2 times 22, okay, and next you combine this 10 raised to the power of minus 3 times 10 raised to the power of 3. Okay, this is equal to 22, 2 times 22 will be 44, and then 10 raised to the power of minus 3 times 10 raised to the power of minus 3 from law 1 of indices. This will be 10 raised to the power of minus 3 plus 3, and minus 3 plus 3 is 0. 10 raised to the power of 0 becomes 1, and 44 times 1 is 44, so our result is 44. Then you ask yourself, what is the unit of this V? And the unit of V is volt. With this, we have successfully solved the A part of the problem. Moving on, let us see the B part of the problem as quickly as possible. B, okay. according to B part of the problem, let's see it. You see, it says a current of 25 microamperes flows in a circuit. Okay, what charge is transferred in a time interval of 40 milliseconds? Okay, here we are given the current, the electrical current flowing through a circuit, any given circuit. This is 25 microampere. Again, this is not the SI unit. Remember, micro is 10 to the power of minus 6, so you change it to ampere. You multiply the 25 given by 10 to the power of minus 6 since it is a micro. Now we have it in ampere, the SI unit. Next, the time taken for the charge to flow in the circuit is 40 milliseconds. You see, this is millisecond. And remember, milli is 10 to the power of minus 3. So this is equal to 40, sorry. You write the 40 first, then you say times 10 to the power of minus 3, and it becomes second. This is your milli. Okay, what is the formula that relates the charge, current, and the time? Our target variable is the charge. So there is a formula that says the current is the quantity of charge passing through a given point per unit time. Okay, if I have this passage and then certain amount of charge passes through this point from this end to this end, Q amount of charge in coulombs, okay, passes, and the time taken to pass from here to here is T seconds. It takes T seconds. Then electric current, okay, is a measure of the quantity of charge that flows, all of it, per unit time. So you divide the charge by the time it takes to pass, that will give you the electric current. This means, this is just rough work. This means we are going to use this formula. We are given the I, we are given the T. As you can see, I is given, T is given, but we don't know this one. So we make Q the subject of the formula. Simply multiply both sides by this denominator, T. So I on the left hand side, I multiply it by T is equal to Q upon T. On the right hand side, I also multiply it by this T. Now I times T becomes IT is equal to T cancel T, I have Q. Now Q is my subject. I can bring it to the left hand side and take this to the right hand side, as this is the convention. So IT. Next, you substitute your I and the T given. Your I, this is 25 times 10 to the power of minus 6. So open bracket 25 times 10 to the power of minus 6. This is our I. And then our T, 40 times 10 to the power of minus 3. 40 times 10 to the power of minus 3. Okay. Now again, we take this and this one, combine them. 25 times 40. Okay, then next 10 to the power of minus 6 times another 10 to the power of minus 3. This is interesting. Now bring your calculator and press 25 times 40. If you press 25 by 40, press equality sign, and you see your answer is 1000. So you have 1000 here, then times 10 to the power of, look at this, this is minus 6, you add it to minus 3. Now this is equal to 1000 times 10 to the power of minus 9, because minus 6 minus 3 is minus 9. And the unit of charge is the coulomb, denoted by capital C. Now remember, this 10 to the power of minus 9 is nano. And nano is a prefix and is denoted by small letter n. So you can simplify this as 1000 nano small n coulomb. That's it. We have solved problem 2. Thank you for watching. Assalamu alaikum wa rahmatullah.